We're live. Yeah.
Okay.
Yeah. I've
Hey,
got one handful of AI, and so I couldn't really do it very effectively. But
only one.
well, so far, welcome to the Spark app.
Yeah, good to be back. Yeah,
Uh-huh.
so we had a lot to think about after our last time. It's kind of cool to get something up and going, but also to see what isn't working. So I did a little bit of follow up. Um, well, first of all, to figure out whether or not ChatGPT or Copilot, which I think they're kind of the same thing, right? The model, I mean, it's
I
the
mean,
same.
Copilot uses ChatGPT, so yeah, it's just a better sort of integration into your development workflow than just talking to a prompt in theory, maybe.
Right, right. Okay, so my first question was, is it learning from the conversation that I'm having with it right now? And I've already suspected I knew the answer to that, and in fact, no. And that's why you get sometimes like wonky results, because on the
Hmm.
one hand, it can seem incredibly knowledgeable, and at the same time, when you try to catch it up to speed, you can ask it like, remove this or don't do that, and it can
Yeah,
respond, but it's not actually learning dynamically.
right.
So
It
okay.
retains the context of your current conversation, but if you say, like, this is wrong, don't ever do that again, it's not gonna not ever do that again.
Well, anyway, I mean, now we're like mincing details, but it would be interesting in further follow up to kind of, and maybe with some guest speakers, to get an understanding of why it's not learning
Mhm.
on the fly. And are there other language models that are now already learning on the fly? And what can we know about the architecture of large language models in general that helps us to understand why they wouldn't learn on the fly, why they need to be trained, like how is the data stored? That is still like a lot of questions for me there, but some of that's academic when it comes to the way that we want to apply it, which is still, and to recap, to provide artists and makers who don't necessarily have a technical background with a natural language interface to introduce AI driven behaviors into hardware. So that might look like pulse width modulating LEDs to have colored light moving around in a work of art. Even better if it's responsive to different sensors. So, sound responsive, maybe accelerometer, so motion, or it can see people, etc. So the idea is like, how can we just play with machine intelligence, get some
Mhm.
really cool effects, introduce it into a hardware context? So the point of that for me is to get it off of my screen per se and into other form factors so that artists can be more creative with other aspects of it. And that's why hardware is so interesting for sculptors, is that it doesn't have to look like a computer. It can look like, you know like,
Right.
for example,
So
this I got jealous because you have so many lights in your background. I was like, I gotta up my game, So I'm like, I'll turn on my gear. And also, I just thought it would be good to like throw this up real quickly and say that I made this light strap without AI, and it is sound responsive and motion responsive. But this was actually the thing that led me to say, gosh, like if I want to change it, make it better, make it different, I just wish I could talk
right.
to it and say, can you tweak it this way a little and this way a little? And I did try and do that somewhat with ChatGPT and got basically nothing worked. Not that and I was really excited about last week. I know that sounds weird because it was like we failed, but I was like, I mean, David is such a good engineer and he's getting similar results to me, which is like, oh crap, it kind of works. It feels like it's working. It feels really cool, but at the end of the day, it's actually not really working.
Yeah.
So
So
here
what
we
we're
are.
trying to achieve is we've been calling it conversational hardware, I think, which is instead of having a LED matrix like the one behind me, and having to write a bunch of code to make it do the thing you want. The idea is that you could just sort of talk to it, and the example that you gave originally was animate a realistic wave pattern or something, I think, like that. And that's kind of what we're going for. And what we thought we might be able to achieve that using with existing technology is using a large language model to create code, to write code. And then initially we thought MicroPython might be a good type of code for it to write because that's an interpreted language that doesn't have to be compiled and uploaded slowly in order to iterate. You can iterate very quickly with MicroPython. So what we tried to do was sort of Wizard of Oz that concept and manually combine the large language model and the MicroPython by just loading up Copilot, trying to get it to write some code for a very simple LED strip. And it didn't quite manage to do that because it wrote CircuitPython instead of MicroPython. So the next week we thought, let's make it a little bit easier. It can't confuse C++. It's not going to accidentally write JavaScript or Lisp or something when we've asked it for C++. So we tried it in regular Arduino C++, and we managed to get it to blink an LED. But then once we tried to do an LED matrix, we got in a fight with it because it kept telling me that the board that I have doesn't have an LED matrix, but here's how I can make one, make it interact with one.
To be fair, though, didn't you also maybe like slightly misidentify the board, or wasn't there something?
I went as far as saying Arduino Uno R4 Wi-Fi because technically the Minima doesn't have an LED matrix, but even when I got super specific, the only thing it knew how to do was connect an Adafruit matrix separately over I2C and do it that way, which is not what I was asking it to do. So we got somewhere with it, and I think it's very interesting kind of seeing, it's magical at first because it seems like it's doing something, and then it's immediately frustrating because the thing it's doing isn't quite what you were hoping for. But
yeah, that's what I ran into because conversationally it's so good, and it responds to you so quickly and uses beautiful language and grammar, and you think, oh my gosh, this is amazing. I just found my new engineering assistant, right? But then you're like, maybe not. Maybe not yet. Maybe not yet, but yeah.
It seems to be overconfident and undercompetent so far. Like, it's like, oh yeah, I can do that. Here you go. And then you run through it. Like, that doesn't work at all.
Yeah. Well, like, what was it just today? Poor Google or some Google affiliate had like a one of those automated cars bump into a telephone pole, like we hear about that with Tesla. I mean, it's not funny. It's really not funny. I'm laughing, but it's not funny. And of course, those things are going to happen in the beginning, but yeah. Machines running the world. Not so easy, right? There's some potential problems that could happen.
So far we've looked at the microcontroller side of the equation, and we used Copilot as our large language model, which we think is going to be how we interact directly with the code. This week, I brought something to give an example of a way that we might implement this in, because our expectation is this is a self-contained box. It's not a computer plugged into a whatever, plugged into. It's going to be a small.
Although David, that is, if we can get that to work, I think that's okay for a lot of artists. Like, I don't mind having a big rig, to get it going. Just saying.
But it's going to be a computer of sorts, but I'm thinking more Raspberry Pi than $2,000 laptop kind of thing. It was my expectation.
Oh yeah. No, ultimately, yes. Right. But I'm just saying that I think for me, in my studio, if I have to have a $2,000 computer that's like connecting to the cloud, that's figuring out how this is all going to work, and then ultimately shoving everything onto my Arduino or whatever, that's okay.
But I think the dream is, you've got your bandolier there, and I think your dream is just to say, hey, change to a red fire animation.
Oh yeah, 100%. No, absolutely. Definitely. Yeah. No, eventually like that or this, I want to be able to just say, hey, instead of having it be like quite so like rainbow colory, could you just give me like only shades of green? Or yeah, exactly.
Yeah. Well, to that end, I brought another show and tell item today, which is
Woohoo!
it's really hard to show this off because this is a prototype. And so this is Pete Warden Useful Sensors' AI in a box. And I'm going to try and hold it up. But this is a prototype before it became AI in a box. And right now it's AI in a bunch of pieces, which again, this is not what the commercial product looks like. This is just what
Okay.
the prototype that he sent me looks like this, but the real thing is much cooler, I promise. But this is what
Oh,
I've got. And so actually,
I think that's
I've
pretty
had it.
cool.
It's pretty cool. I've had it in, oh no. So I was going to say, I've had it in transcription mode this whole time that we've been talking. But as soon as I pick that other end of it up, the display stopped working. So let me just wiggle these wires around a little bit, see if I can get the display working again. It was working a
I mean,
second ago.
of course that happened, right? Of course it, like, the wires come unplugged right
I mean,
away.
it's literally just like a little
It wouldn't
wire
be a
wiggling.
demo.
But as you can see, it's been keeping track of everything we're saying and talking about wiggling wires and things like that. So
Cool. It's like
this is,
Alexa communicating with the mothership.
well, but this is the important thing. So this is the whole point of AI in a box, is it is in a box. And so it's
Mhm.
not communicating with anything. That's the whole,
Oh,
that's what
oh,
the beauty of this is it everything stays inside the box. It is local, it's not connected to the cloud, and that's what's cool about it.
yeah. Okay, David, I'm glad you mentioned that
Yeah.
actually, because I realize this is very much an opinion, but I am I'm very much in support of just AI in general going on a localized hardware model. I was so happy when Apple said they were really looking at the hardware implementation, because it's already bad enough that we're sending our data all over everywhere and it's God knows what's happening to it. So it's pretty nice to be like, yeah, here's my AI in my box. Thank you very much. Sometimes
Yes,
that's actually really
I was just
nice.
I was just capturing your opinion here so that we could see exactly what your thoughts were and then keep them inside
Okay, cool. Okay, so,
our
yeah, well, it's all over YouTube anyway, so,
box. So
we're not in
it,
a box.
so the AI in a box has a couple different modes, and right now this is caption mode. And if we turn it into chatty mode, actually, I have to say it with like an American accent. Oh no, it worked. Okay, can you hear that chatty mode? So the speaker is a little bit dull, and now it's picking up everything that I'm saying to you, which is
Is it? Oh, we have a third person on our live stream. Hi, chatty mode box.
our first official guest. So this is,
I love that.
similar to Chat GPT or the other models that we've been talking to. We can ask it questions, we can give it prompts and see what it does. So what would we
Are
like to do?
you are you willing to join our live stream? It's like,
That sounds like a great idea.
woohoo!
Some sample prompts. More questions to use in our conversation with the chatbot. I'm looking forward to hearing its responses and learning more about how it works.
You are the chatbot. I'm covering the microphone right now, so hoping it doesn't pick up our conversation. But
Okay.
are you able to help us write Arduino code?
Yes,
Yes. Oh,
I can definitely assist you in writing Arduino code. Do you have a specific project or task in mind that you would like me to help you with?
Can you write a LED blinking Arduino sketch?
Sure.
lots of pregnant pauses.
It's going. Stuff's happening on the screen. I wish I had a better way of sharing the screen if I could like VNC into it or something. Let me turn my light off here and see if we can. There we go.
Next.
So it is outputting it, and it is quietly and slowly saying what it's doing.
Arduino board using the appropriate pin numbers. 3. Write the code to blink the LED in a loop until it reaches your desired frequency. Here's an example of a simple sketch that blinks an LED at a rate of 10 Hz. 4. Finally, save and run the sketch. 5. Turn on the LED. Use the delay function to pause the loop for a certain amount of time.
So that was like a recipe of how to do Arduino stuff as opposed to, directly.
I know. I'm having this moment of like, please buckle your seatbelt low and tight around your waist and tighten the strap.
Unexpected item in the baggage area.
Exactly.
So,
oh my
again,
God.
this is a prototype. This is not the final version, but you can see how, it's, this is, I'm going to unplug it now so I can show it off better now that we don't need to talk to it anymore. But this is a Raspberry Pi size device, AI in a box. It's not a Raspberry Pi in here. It's a rock chip something or other. But, I don't have a Raspberry Pi on my desk. Oh, actually, I do. I have a naked Raspberry Pi PCB on my desk, and it is about the same size as that, just to give you an idea. But this is a single board computer, reasonably powerful, but not anything ridiculous. It's not an NVIDIA Jetson or anything of that class. And
well, also just quickly, like, what's a
Yeah.
how much does the NVIDIA chip cost versus how much this costs? Just and Raspberry, yeah, just curious.
Yeah, great question. So this is the Useful Sensors AI in a Box crowd supply project. And again, this is not the real one because the real one combines these two pieces. So it's like a screen with the Raspberry Pi on the back kind of thing, all in one piece. But on the crowd supply campaign, it was $359 for everything. And again, it's a more cohesive thing. It hasn't got microphones and speakers hanging out of it. So $359 for that. A Jensen Nano by itself would be $500 just for the board. So yeah.
And what can you do with that? Just curious. If you buy that, a Jensen
Nano?
Yeah, what can you do with it?
So the Nano is very specifically designed for AI projects. It has very specific hardware that's optimized for the types of operations involved with running these models. And so it's not as much what you can do with it. You could do similar things with the Raspberry Pi or other board. It's just how powerful it is in terms of the number of operations that it can do. It's just that much more powerful.
Well, so I'm just trying to get a feeling for that. Like, would a maker, a hacker buy an NVIDIA board? And if so,
so that's what this product is for. The Jetson Nano is specifically sort of, maybe you built something with a Raspberry Pi and it's not giving you the power that you need for your application. And this is a way just to get a bunch of more power in a similar form factor, also requiring a bunch more literal power like electricity.
Okay, so if I'm a researcher and I want to build like a really sophisticated, let's just make it extreme. Let's say I want to build a robot that can walk like a human, so something very complex. Okay. Yep. Would I be able to do that with a single NVIDIA chip, or would I need multiple ones? Like, I'm just wondering kind of.
So first of all, I wish I'd have grabbed, I have some just out of reach over there. But the latest, the new one, it's a carrier board. And so you know how the Raspberry Pi, you can get a regular Raspberry Pi or you can get a CM4 module, which is the same. Well, there's different variations, different amounts of RAM and storage and things like that. But generally, there's the Raspberry Pi sort of dev board, and then there's the Raspberry Pi CM4, which is smaller and more appropriate for sort of shoving into other hardware. And so with the current generation of the Jetson Nano, it's the same thing. It's a carrier board with a compute module on there. And so that compute module could actually vary, and they have a very specific sort of trajectory of I mean, you can still use the old less expensive one, which was like, I think the cheapest one was like $69 or $99. It's just the new one it starts out at $500, but they have a whole trajectory of like, if you need this performance, use this. If you need this performance, use this. Up to, I've got over there Xavier, which is about $2,000, I think, and you know, they've got a very specific like whatever power you want, they make something that can kind of do that.
Okay, can you translate what you just said into simple application examples? They might not be 100% accurate, but that just give me a flavor of like, okay, Kelly, if you want to have a piece of hardware that can blink an array of 10 by 10 LEDs, you don't need AI, you just need an Arduino. If you want to make a car that can use sonar to like not hit the wall, you need this chip. If you know, all the way up to like the most fanciest AI enabled large language model thing that I might use in hardware. What can you just
So we have at the simplest level, we have Arduinos. These are microcontrollers. This is the R4, so it's the 32-bit one, which is more fancy than the original, than the first three generations, which were just 8-bit. But we've got, and this is also a 32-bit Arduino. So these are great for blinking LEDs. You can do a decent amount of machine learning on a like M4 microcontroller. So this is my favorite board for machine learning. That's why I have a bunch of them, because
define a decent amount of machine learning. What does that look like?
So the kind of things you can do with this, I love that you're pushing me on it, because this is exactly what people want to understand. Is you could do you can do sort of image classification. You could do, you know, what is that? Recognizing a bird song or something like that. Those are the kind of classes of things that you could do with these boards. These are inexpensive microcontrollers, $20-$30 kind of things like that. Then perhaps and then there's different, even within the microcontrollers. So Arduino, for example, has their Pro line, and their Pro line, at the top of the Pro line, they have, you know, they're pretty much focused on AI for the most part, and like industrial applications with the Pro line. And if you have this is just the box, but if you have a Portenta, this has a lot more power than the, this is a, go ahead.
So at what point would I say my entry-level Arduino is not good enough for my project? Let's say I'm a biologist that wants to carry a handheld widget into the Peruvian rainforest, and it is carrying a database large enough to identify any bird song, any season, any gender. So basically, like any song that could be thrown at me in the Peruvian rainforest, my widget would be able to hear it. Could I do that with an entry-level Arduino, or would I need a more?
Might be somewhere in between. I don't have this one, but there is so this is the big the biggest, baddest Arduino. Actually, it's not. There's the bigger one than this, but this is the sort of flagship one for the Pro line, which is the Portenta H7. There's actually the X8, I believe it's called, which is
like, could I use that? Could I use that to like communicate with whales? You know, like, did you hear that project recently where it was such a cool project? They were.
You mean the one that translates the whale language? Yeah.
And then was singing back though. So there was apparently some kind of AI that was not only listening but also singing back. Like, could I do that with?
I'm not sure how the project worked, but in a more familiar example for me at least. So this is the Portenta and Portenta Vision Shield. And so this is specifically made for machine vision projects. So if you had something of this class that is doing some kind of object recognition, then maybe you're like, oh, it's only getting like 4 frames a second. This is not good. And so then you're like, I want 30 frames a second, 40 frames, 60 frames a second.
Okay.
You go up to
Okay.
more powerful hardware. Then in terms of
Okay.
your
Okay.
NVIDIAs, again, the kind of things that your instincts were spot on there, because the kind of applications you're going to be looking at there would be a lot of robotics. And so the example you gave was perfect, because again, if you had sort of LiDAR and you're trying to map out your room, maybe for your entry level project, you were using a Raspberry Pi and you let it sit there and just like look around and map out your room for like an hour, and that's fine. But then you were like, actually, for my real thing, I want it to be able to go in the room and start doing stuff immediately. So that's when you
Right.
might upgrade to the NVIDIA gear to be able to do stuff kind of more in real time.
So like for VR, or if I were playing paintball and the room or my outfit were continually responding to my environment, I'd want an NVIDIA chip in my backpack so that it could just be like thinking about everything, processing a ton of information.
Yeah, it's really just
Yeah.
about optimizing for
Okay.
performance. There are obviously like special things that are capabilities, but it's really just the kind of, the story that we put together in terms of like, I can do this with this thing, but I can't do it very well. So then I move up to this thing, which can do this, but it can't really do that. So I move up to this thing, all the way up to the Xavier or whatever beyond there.
So I want to be able to talk to AI and have it tell me what chip I need to buy.
Yeah.
And, because I mean, even having like worked in electronics for so long, I mean, it's so difficult sometimes to figure out like, what hardware do I need exactly? You don't want to buy a $500 NVIDIA board if you don't need it, clearly. I don't even want to buy a $250 AI in a box if I can get away with a $30 Arduino Uno or whatever. Like, I mean,
Well, I did an experiment with that the other day where I fed the make boards guide into a large language model and had it describe back to me a comparison of boards and which boards were the best performance, or kind of asked it some questions, and it did a pretty good job.
cool. That's great. Yeah. I
Yeah.
mean, if AI is going to cost us a lot of money, it needs to save us a lot of money too. Just saying. Like, AI, what's the cheapest version of you that I can buy? Yeah, just saying. Okay, cool. So, all right. So are we going, do we have anything this week to move forward and try and do something more interesting with LED animation, or where are we with that?
I didn't bring any gear for that because I brought the AI in a box for today's show and tell.
Yeah,
What are we thinking for? I don't know
that's
what we're
okay.
thinking
That's
for
cool.
our. So the next
Well,
thing that we're definitely going to do with that, though, is I'm going to have my friend Ubi from Arduino come on later in the month, and he's going to show us, because he uses stuff all the time. Like, I hadn't used Copilot before we decided we wanted to try it out, and I've used MicroPython, but I'm not a MicroPython expert. And he uses Copilot all day, loves it, and loves
okay.
MicroPython. And so while we kind of got things working a little bit, but stumbled a little bit, he's going to give us kind of the expert mode overview of like, I do this all the time. Here's how it works. It's great.
Okay. Okay, that's awesome. That's awesome. And also, and I don't know whether we're going to do this or not, but just kind of speaking about it on the fly. What other models should we be looking at? Like, someone asked me that this past week, and I was like, we're just kind of doing this impromptu and learning as we go, but like, Perplexity, Claude, I don't know, there seem to be, everyone talks about ChatGPT, myself included, because that was the first, bot that I interacted with. And now I'm getting Google summarizing everything with AI, which is quite interesting, but I'm not, well, obviously, I mean, we're also used to just typing in something into a Google search field. So ironically, we're being, segued into working with their chatbot without even really asking for it, so that's kind of interesting. But maybe Google is just like specialized for searching and isn't really what you would use if you wanted to develop hardware like we're discussing. But what about other,
So, when I was talking to Ubi about what we're going to do on the show, he says that having the AI write code for us thing is going to take 30 seconds. And what are we going to do with the rest of the show? And so
we're going to ask him a million questions.
True. But we looked at, when I spoke to him most recently, we looked at some other models, exactly what we were talking about. So he's been using a tool called Olama, which is an open source sort of container for running different models. And so I'm going to have him show us what he's been doing with that as well, in terms of grabbing models to evaluate and use locally, because that's kind of, we've got all of our microcontroller stuff over here that we've talked about. And then we need some kind of large language model solution that is kind of nebulous and TBD at the moment. And so I'm hoping we can learn from that as well to help define what we want to do on that side of things.
Yeah. And I'm also I still feel like I need a lot more discussion around what these large language models are.
Mm-hmm.
And I would really like to understand more under the hood. Yeah, what are they? How are they different? What does OpenAI have that, maybe Elon Musk does or doesn't have, or Google does? And it's just merely to say, like, are they all, what does it mean?
Yeah.
Because you and I started this conversation a couple of weeks ago saying how we've worked with machine intelligence for decades, right?
Yeah.
And we never called it AI. It's not that we weren't aware of that name. And I guess AI was always this idea of, like, a software entity that had this kind of, like, consciousness, like, ability to think, right?
Mm-hmm.
Whereas our experience of AI, or not AI, I'm sorry, machine intelligence, or just writing code for forever, was more like, okay, there's this thing that I want to do, so let me analyze, like, what it would take logically to make that happen, so I can write a series of instructions that cause my computer to then execute those instructions. And it's like boom, 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 boom. So it just felt very mechanistic and not lifelike or intelligent or responsive or learning or whatever.
Mm-hmm.
And there's something with these, with now what we call AI, there's this idea that, or it feels like it, I'm not saying it's real, but it feels like suddenly, that whole model of machine intelligence has been upended. And now, like, code is writing itself, and machines don't necessarily need to tell us to tell them what to do all the time. They sort of know, or they can kind of figure it out. But how true is that? Again, when I said that I looked into ChatGPT and discovered that it wasn't, like, really learning from the conversation at the moment, it's like, well, okay, so then what exactly am I interacting with? And I just have a lot of questions about that.
Yeah. So that's not my area of expertise, but we've had our first guest today, which was an AI in a box. We'll be off
Wouldn't
next
that be
week.
funny if we kept inviting AI to, like, be a guest?
So I'm going to be gone to Teardown next week, so we'll be skipping next week. But then later in the month, we'll have Ubi come on to talk about the things I mentioned, and then maybe we can line some other guests up.
That'd be
my
awesome.
friends from ARM and NVIDIA and Raspberry Pi and Arduino,
Yes.
things like that, to
Yes,
answer some of those
yes.
questions. Yeah.
Please, that would be so good. Bring them on and say, what's going on? Right?
Awesome. Are we ending it there then?
We're here. We're done. Yeah.
Okay.
I'm done anyway. Yeah.
All right. I don't even know how my arms work anymore. I didn't.